Okay, right. Now share screen. Go back to this, then share. Okay, it is recording now. Uh, so since this point 3, -1 is a point on this curve, the coordinates of this point must satisfy the curve. So I can take this x and y here and substitute into the equation. So by doing that, I form an equation. I call it equation 1. Okay. Next, because they say it's a minimum point, I can also use dy dx. I can also use dy dx to as equals to 0 to form another equation. Okay, so although we are given 1 point, but we can form 2 equations. Why and how? Okay, uh, the way is by substituting this point into the equation. Then the second equation is by using dy dx. So you find dy dx and put dy dx equals to 0. So you can get another equation. So you find this p in terms of q or q in terms of p, and you substitute back into equation 1. Okay, so in this way you can eliminate the p and you can find out the values of q. Okay, one more time. You can form 2 equations. One by using the point itself and substitute into the function. Second is by using the point substitute into dy dx. So you have 2 equations. So you can find the 2 unknowns. Okay, you can find the 2 unknowns. So form 2 equations, find the 2 unknowns. Okay, you have 2 answers here. You have 2 answers, 2 sets of answers. Q equals to 4, P equals to 2, or Q equals to 2, P equals to 4. But the question say Q is greater than P, so we select this pair, Q4, P2. Okay, right. So this video, this is recorded. So when I post this in the YouTube, you can refer to the answer. You pause and check the answer for number 4. You can also pause and check the answer for number 5. Okay or not? Can you see number 5? Number
Yes,
5
sir.
here. Is
Yes, sir.
your picture blocking the text here? No, your picture not blocking. Or I put it this way like that. Like that, then it's not blocking. Okay, right. So the next one. Okay. This is question number. We asked question number 7. Where is question number 7? Yeah, this is question number 7. Okay, right. So in question number 7, you are given the curve, and you have on this curve you have 3 unknowns, A, B, and C. So you have 3 unknowns. How many uh, how many equations you have to form? A, B, C. How many equations you have to form? You have to form 3 equations, but you are only given 2 points. How to form the 3 equations? You substitute this point, you form 1 equation. You substitute this point, you form another equation, right? So I start by substituting this point, 0, 6. So I substitute 0, 6 into the equation. I can get this C equals to 6. Okay or not? Okay. So you can find the values, the unknown values, by substituting uh, the point into the equation. Okay, second one. I also use this point, since this is the minimum point or turning point. So this point must satisfy the equation. This point must satisfy the equation. Who is this Galaxy A Pro 9? A9 Pro. Okay. So you don't know the name, don't let them in. Don't know the name, don't let them in. Okay, right. So I use this point, I substitute into the equation, right? I have another substitute into the quadratic equation. I form another equation involving x and y, involving a and b, right? So after substituting the 2 points, I've already formed two equations. So can you guess how to form the third equation? How to form the third equation? Anyone?
B equals to negative 3 minus A.
No. The next equation you can form by using dy dx. Okay? By using dy dx equals to 0. Okay, so I use dy dx and I make dy dx equals to 0. So I can form another equation. So now, solving these two equations simultaneously, I can find the values of a and b. Okay, solving these two equations simultaneously, I can find the values of a and b. Okay, right. So how to solve these two equations? You just substitute, right? Substitute equation, no, use equation 2 minus equation 1. So you can find the values of a and b. So probably, Karen, you don't know this question is because you don't know how to form the three equations. Okay, so now I go through again. First equation using the first point. Second equation using the second point, you substitute into the quadratic equation. So you can form two equations. The third one comes from dy dx. dy dx you put equals to 0, you can form another equation. So uh, you can easily solve the three equations. Okay, so we move on to the next question. Next question is number 57. Okay, you see don't know how to do 57, so we look at number
Yes, yes.
57. Okay, so number 57, we read the question. We are given two equations. Okay, the first equation, x plus y equals to 10, and the second equation, p equals to x square y. So p equals to x square y. I can't, yeah, p equals to x square y. So I substitute one into another. 周喜 what? Who is this? Chiu something. Who is this? Anyone with Chiu Chow? Yeah, for E is it? Chow Chiu Xi. Don't know why. I don't know how to read Mandarin. Okay, never mind. Let them in. Who is that? Who is the Zhou? Zhou what? Not Zhou. Chiu Chiu Chiu. Zhao is Zhao. Okay, right. You have two equations, but you have three variables there. So you try to replace either one of the variables, x or y, inside this equation P. So in this case, I make y the subject of the formula, and I try to substitute into equation 2 to eliminate one of the variables. So once I eliminate one of the variables, you can see that P consists of one variable x. So you can actually substitute, right? You can actually substitute the values inside. Okay, you substitute the you can substitute the variable inside and eliminate one of the variables. So your P become only involving x or only involving y. Now, why is this important? Because if you want to differentiate, you cannot differentiate from equation 2. You see, this equation 2 has x and y. So you only know how to differentiate one variable. If there are two variables there, which variable are you going to differentiate? So you cannot. So you have to use equation 1, substitute into equation 2 to eliminate one of the variables. After eliminating one of the variables, you only get p in terms of one variable, and in that case you can easily differentiate. Okay, you can differentiate. So we look at it. So we can find dp dx. And since you want to find maximum or minimum, the dp dx must be 0. So this is my dp dx. 10x squared become 20x. Negative 3x cubed become negative 3x squared. So after differentiating p with respect to x, and I put it equal to 0, I found two values of x. So one value will give rise to the maximum value, and another x will give rise to the minimum value. So which is which, you have to decide, right? You have to decide. Okay, so now I find the 2p over the x squared. The 2p over the x squared is 20 minus 6x. 20 minus 6x. And 20 minus 6x. And I substitute x to 0, I get positive. So this one will give rise, x equal to 0 will give rise to minimum value. When I put in x equals to 20 over 3, the 2p over the x squared is a negative value. So it means that this value of x will give rise to the maximum p. Okay, right, so we take this one, maximum. Did they say maximum? Yes. Find the values of x and y such that p is maximum. So this one will give you the maximum p. So I still need to find the y. Okay, knowing the x, then I substitute back into equation 1. I can find the value of y. So these are the values of x and y that will give rise to a maximum value for p. Yes, what? What's his name? Zhao Zi, ah? The 4E girl, what's his name? Zhao what? What's her name? Why you put up your hand? Any question? Yeah, you just turn on your mic and ask. Zhao what? What's her name? Jiu or Zhao? The Chinese girl? Huh? You have a question to ask, please ask now. Where is she? Hello? Yeah, she put up the hand, huh? Where is she? Zhao
Sir, Chao Jiaqi.
Zhao Jiaqi.
Yes, John.
What do you want to ask Zhao Jiaqi? No, no question, we carry on, Zhao Jiaqi. Okay, no question, Zhao Jiaqi. Where are we now? Okay, so meanwhile, since Karen asked 57, so I explained 57. So one more time. Okay, Karen, I repeat, listen. Now this question, we have 3 variables. So your aim is to eliminate one of the variable. Okay, so how to eliminate one of the variable? So from the first equation given to you, you either find x in terms of y or y in terms of x. So after that, you substitute into the function p. When you substitute the function p involves only one single variable, that is x. So you can easily differentiate to find the turning point, to find the maximum or minimum value. So after differentiating, you have 2 values of x. So you do not know which value will give rise to the maximum, which value will give rise to the minimum. So you have to find the 2p, the x squared, and substitute the x inside to determine whether it's positive or negative. So the negative one will give rise to maximum value, and this is the one that's negative. But they want us to find the value of x and y. We only know the value of x. So we have to substitute back into equation 1 to find the value of y. So you find the value of y. So far, okay, Karen?
Yes, sir.
Okay, right. So we go on. The rest, 56 and 58, you just pause. Okay, you pause. When I post you the video, you pause, then check the answers. I'm not going through 55 and 58 because you all never asked, right? But I provide you with the answers, you check it yourself. Okay, right. Next one. This one you ask is what? 59. 60 or oh yeah,
yeah.
60. 60 and
wait.
So I'm going to ask 60 and I'm going to answer 60 first, right? So before I answer, I just read through the question first. Find the coordinates of the stationary point, y equals to blah blah blah. Determine the properties of the point, hence sketch the curve. Okay, right. Now, to determine the point, maximum or minimum point, you have to find dy dx. Okay. This one is Yang Wan Li here or not? You didn't differentiate the second part. This one. Okay, so you cannot get 100 marks because of this. This one, you have to use the product rule. You only show one part, the first part, the differentiate, this part, you only show this part. You didn't show this part. Okay, let me explain how to differentiate. You differentiate the x, become 1. Then the second function, x minus 5 square, you just keep. That's why you get this term here. Now, in the second part, you keep the x. That's why we have this x here. Keep the x. Then differentiate the 2, bring down the 2. Then this thing, the power less by 1. And differentiate the inside again. So you have 1 here. So this is the complete differentiation using the product rule. Okay or not, Yang Wan Li. This is the mistake you make. Okay? So cannot get 100, right? So after differentiating, you have to factorize. Factorize, then you are in this form, in the factorized form. Because we want to find the points, okay? Unless you factorize, then you can find the points. So to find the points, you have to put dy dx equals to 0. Okay, to put dy dx equals to 0, y dx equals to 0, then x equals to 5 or 5 over 3. When x equals to 5, y equals to 0. When x equals to 5 over 3, y equals to 500 over 27. I think this value Liu Ying also get correct. Only question she doesn't know how to do is this one, number 61, she doesn't know. The rest she knows.
Yeah.
I remember because I mark the answers. Okay, right. So as usual, we proceed as usual. Find dy dx, make dy dx equals to 0 to find the turning points. So we have found 2 turning points. Next, I would like to know which turning point is maximum, which turning point is minimum. So I have to find d2y dx squared. So after finding d2y dx squared, you substitute in the value of x. When x equals to 5, d2y dx squared is positive. When x equals to 5 over 3, d2y dx squared is negative. So that means this is the maximum point, this is the minimum point. Okay, now you only know the value of you have to tell which one is maximum minimum. So the answer Z50 is minimum, 5 over 3 527 is maximum. So you mark these 2 points on the curve 50. Where is 50? This one 50. You mark this point here and you curve it this way so that it is a minimum point, because 50 is minimum, so you make a minimum point turn around like this. Then another one is 5 over 3 527. This is the point, and you mark with the maximum, and you join up the maximum and minimum, you will get this type of curve. You have learned this type of curve in your mathematics, Form 5 first chapter or second chapter. What chapter is that? Form 5 mathematics. This type of curve, right? So one is minimum, one is maximum. It's like this. Okay, right. Okay. So that's how you draw the curve. Any question? Any question? Yeah. Let me see, got any hands or not? Anybody put up their hands? Nobody put up their hands. Let me see. Okay, nobody put out a hand. So we continue with question number 61. This one many people don't know how to do. I mean, not many. All that pass up, they cannot do this last part of this question. So everyone cannot do, I assume. Even those pass up one, I didn't pass up, I don't know lah. Okay, right. This is the equation number 61. There is an equation, and this equation has 2 unknowns, A and B. And you are given how many points? You are only given 1 point. You are only given 1 point, the stationary point. So how to get 2 equations from 1 point? Okay, never mind. The simplest one will be you substitute the point into this equation. Substitute the point into this equation to form one equation. To solve this problem, you have to form two equations. Now, where the second equation come from? First equation, you substitute the point into the function. Second equation, you substitute it into dy dx, because this is a turning point. So you have to find dy dx. Okay. Now, after finding dy dx, you substitute the point into dy dx, make dy dx equals to 0, and you come up with the second equation. So by using equation 1 and equation 2, you can solve and find the values of a and b. Okay, find the values of a and b. So how to solve equation 1 and 2? Just minus. Use equation 2 minus equation 1. You can find the value of a, then substitute back, find the value of b. So after that, you rewrite the equation. Okay, you rewrite the. Okay, now this dy dx, find dy dx again. Why we need to find dy dx? How do you know that we need to find dy dx? Now you look here, the question that coordinate of another stationary point. Now you are given one stationary point, so you need not find this stationary point. You need not find this 1, -2. No need to find. But actually, this is a cubic equation. Cubic equation, like the graph drawn here, has two turning points, and you're only given one. So you have to find the other turning point. So how to find the other turning point? You have to find dy dx and put dy dx equals to 0. So how to find dy dx? You see, you have to substitute back into this equation here, the values of a and b, then differentiate one more time. So substitute, differentiate one more time. This is your dy dx without a and b, all without any unknown a and b. So this is it. The dy dx is 9x squared minus 8x minus 1. So you have to put dy dx equals to 0. Put dy dx equals to 0. So put dy dx equals to 0. You have to find the 2 points. One is the two values are x equal to 1 and x equals to -1/9. Now x equals to 1 is the point given here, 1, -2. Okay, if you substitute into the equation here, right, you will get 1, -2. It is actually given. So this is not the one that you want. So you take the other one, x equals to -1/9. So this -1/9 is not given. So this is what they meant by the coordinates of another stationary point. So this x equals to -1/9, you substitute into y, you will get another turning point. So this is the other turning point. Okay, right. So number 59. Okay, number 59 is here. Number 59 is here. Okay, so after this, when I pass you the video, you pause and copy the answer number 59. Okay, that's all for today. Now before I stop, the next topic is what? Rate of change or small change? Karin. Next topic is what? Rate of change or small change? Oh yeah. No, not yet. Problems involving maximum and minimum. Okay. Next topic is problem. So they will give you different shapes or different relationship. You have to differentiate them and find the maximum value of the volume, maximum or minimum value of the radius or the side of a square, and so on. So we look at problems involving maximum and minimum. I will give you the question under assignment, right? So they say time is running out. 10 minutes left for us. So this is it. Okay, right. Any question? Any question? If no question, then we end here. Right? We end here.